Hi friends, welcome to the Unit 3 Day 2 notes. This one we're going to jump into long division and synthetic division, excuse me. So with synthetic division and long division, our goal here is to write a polynomial of a higher degree. So anything above a cubic really, so even a cubic, so a quartic or a quintic, any of those higher degree polynomials, our goal is to basically factor them into smaller pieces. So by factoring them into smaller polynomials, what we can do is we can essentially take a longer or more complicated piece of problem and factor it down into smaller parts, and then we can analyze those parts to give us useful information about either the graph, the polynomial, or the problem itself. So for this particular one, we're going to do long division first, and we're going to divide x cubed minus 4x squared plus x plus 6 by x minus 1 using long division. Using long division, we put x minus 1 over here to the left, and then it's going into x cubed minus 4x squared plus x, and then plus 6. So what's happening is we're going to line everything up vertically in the same degree power exponent. So I'm going to ask x goes into x cubed how many times? A lot of students get this wrong because what I'm asking is this. I'm asking x goes into x cubed how many times? So that's the same as saying what's x cubed divided by x? Well, x cubed divided by x is x squared. We subtract the exponents. And that's true here as well. So in this particular instance, when I take x cubed divided by x, I get x squared. That lines up here with this part. So I put an x squared here. Then when I multiply through, I take x squared times negative 1, which gives me a negative x squared, or minus x squared. And then x squared times x gives me x cubed. Now, if you remember from the previous video, we talked about how we subtracted the entire thing here when I talked about subtracting that 42. Here we need to subtract this entire thing as well, except there's multiple terms there. When we subtract, in this instance, we have to be careful. We're subtracting this term and we're subtracting this term. If you think about when we subtract a negative or subtract a minus, it becomes a plus. So now, when I go through and combine these, my x cubes cancel, and they always should unless you picked the wrong thing here. And then negative 4x squared plus x squared is a negative 3x squared. And just like you did with bringing down the next part or next piece, we do the same. A student asked, can I bring down all of these pieces each time? And the answer is yes. In fact, that's one way to go through and work through the problem. However, you won't multiply through or use all of the pieces, so I just bring down the next term. X goes into negative 3x squared how many times? Again, negative 3x squared divided by x is going to be negative 3x. So negative 3x is a linear term, so it will go right here, negative 3x. Negative 3x times negative 1 is a positive 3x. Negative 3x times x is a negative 3x squared. And what you should see when you go through, you should see the exact same thing here before we go through and subtract. Again, when we subtract, we change the signs. So this negative 3x squared becomes a plus 3x squared, and this positive 3x becomes a minus 3x. When I combine, again, these cancel as they should. And if I combine x minus 3x, I get a negative 2x. Then I bring down the plus 6. X goes into negative 2x again. So negative 2x divided by x is a negative 2. If you notice, each time we go through here, we're coming down, we're lowering the degree by 1 when we go through this each time, and you should. You should end up with a degree less as you're going through and dividing, because this is a linear degree. So then we're essentially dividing out a linear degree each time. Negative 2 times negative 1 is a positive 2. Negative 2 times x, negative 2x. Again, just like we talked about earlier, we need to change the signs. So this is a plus 2x. This is a minus 2. So I'm left with a 4. There's a lot of different ways to write this 4. What I want to talk about is kind of the normal notation. This is, again, called the remainder. So we have x squared minus 3x minus 2 plus 4 out of x minus 1. Just like we did up above when we were talking about having 1 out of 6. This is 4 out of the x minus 1. So this 4 is your remainder with the x minus 1 as part of it. So let's talk about like visually what this represents. If I multiplied x squared minus 3x minus 2 plus 4 over x minus 1 by x minus 1, so if I multiplied this by x minus 1, I end up back with x cubed minus 4x squared plus x plus 6. This process is called the division algorithm. You learned this division algorithm when you were younger. This is another way to apply it using algebra. So the dividend is equal to the divisor times the quotient plus the remainder. Let's talk about what that means. The dividend is the part that is we're dividing. So this is the dividend. So the x cubed minus 4x, x cubed to minus 4x squared. Is it minus 4x squared? Yeah, minus 4x squared plus x plus 6 is equal to the divisor. So that's what we divided by. So the divisor in this case was the x minus 1. So that's equal to x minus 1 times what our quotient was. That's kind of the result or answer that we obtained. So this is x squared minus 3x minus 2. X squared minus 3x minus 2 plus the remainder. The remainder in this case was plus 4 out of x minus 1. So that's another way that we could see it. Now, multiplying through x minus 1 times x squared minus 3x minus 2 and then adding 4 over x minus 1 is going to give me this result back here. The remainder in this particular problem, we are accounting for the divisor because we've divided through. So in this particular instance, I would need to just have the 4 in this case because we've already accounted for that x minus 1. So that's just plus 4 here at the end. We're going to talk about other ways to represent this. Note that if x minus 1 was a factor, this would be plus 0 instead. So here, we're talking about the division of polynomials. Given the unique polynomials p of x and d of x, and that neither of them are equal to 0, then we can say q of x and r of x such that. So what's going on here? Basically, I'm saying that if I divide out a polynomial from something else, if I divide a polynomial out of a polynomial, I'm going to end up with a quotient plus some remainder. And that's all that this says here. That's really what it says. And we want to point out that r of x is either 0 or degree is less than the degree of d of x. So your remainder has to be smaller than, less degree, than what you're dividing by. So in this case, our remainder was 4. In this problem, 4 is less than, degree-wise, x. This is a constant term. 4 is a constant. Your x minus 1 is a linear term. So because you have that, we have a degree that's less. So this is a valid result or a valid answer. Join me in the next video as I go over synthetic division and a couple of examples of that. Have a good day.